Well, welcome, Henry, to another episode of the podcast. And today we're going to do a bit of a deep dive onto a specific role or a persona that works with CFS, and that is the engineer. So let's just start off. I use the word engineer, but how else are they described? What is the role that we're talking about here?
Yeah, I guess two most common ones would be civil and structural engineer. So we have both that work for us. That'd be like common degrees that they would do. And they're in our organisation as well. They're basically empowered to kind of bring our products to life, really. So work out whether they work, how they work, and make sure that we're producing designs that are fit for purpose.
And what's the difference between a civil and structural? Is that interchangeable, or do they do
There is a slight
things?
difference in terms of what they study. They're like modules at university, etc. But I mean, there's some basic fundamentals which are shared, and then in structural it just goes a little bit further in certain topics.
And so, what's their role? How do they differ, from an architect? What's the engineer's role?
So I would say an architect makes the building kind of functional, fit for purpose, obviously has roles in getting the thing through planning, a very kind of wide role in that aspect. And then the engineer would be responsible for making sure that the thing can be built to the right codes, and just making sure that it can stand the test of life, really.
And a CFS project is typically a high-rise building or an industrial project. So can you just talk a little bit about what does that team look like? Is that one engineer, or is it hundreds of engineers working together on one project?
Yeah, I think it depends on the contract type. So sometimes you get like a design and build contract where like a contractor or developer will have like a big team in-house and they'll be responsible for developing the scheme. Sometimes you've got multiple engineers, so an engineer might be responsible for the piling, for example, making sure that those calculations are done correctly. Someone else might be responsible for doing the frame. They might be the same company. Then you would have us as obviously advising on certain fixing strategy. So there's a big group of people that fundamentally have similar skill sets, but all combining on a project.
So there's quite a lot of specialisation, I guess, like doctors or dentists. You specialise in a particular type of engineering, and the project brings the right brains to the
totally.
task.
We were actually at an engineers yesterday, and they specialise, for example, in precast, and so that in itself is a speciality. There's nuances to it, same fundamentals to the role, but there's certain bits of experience that you pick up by specialising in a particular area.
And so I'd assume within that situation, then you've got multiple different engineers and types of engineers working on a project. But from the engineer's perspective, they're probably also working on multiple projects at the same time because of their specialisation. So are they juggling lots of different things at the same time? And how does that tend to work?
Yeah, they are. I think, certainly speaking from our own experience as well with our own engineers, they often working on a couple of projects at any one time and making sure that, construction usually works to fairly tight timelines. And so that means that you're balancing responsibilities and you're working to quite tight timelines. And so obviously that carries a level of stress with it.
Different timelines, and I should think having to follow the right building regs as well. What's your experience of how engineers are able to keep on top of those different regulations as they change?
Yeah, and I think they're pretty good at being able to keep on top of those. But I think the one thing you want to make sure is that there's a lot of products that go into a building that we're talking about, and so there's potentially a lot of special knowledge that's required, obviously in individual areas, to make it happen. And I think it's not necessarily they can't keep on top of the current, regulations, but when you flow that down all the levels, then it becomes quite challenging.
And I guess building on from that, when you're speaking with engineers, what are the things that are keeping them up at night? What are the things that they're most concerned about in their work that they're doing?
I think they fundamentally that the design they've produced is correct. Ultimately, that's the single biggest thing that I would personally worry about, just making sure that the calculations you've done are as per the standard, or the product that you've specified is fit for purpose, etc.
Yeah, and how do they go about that? How do they know that it's buildable and is going to be fit for purpose?
So I think there's certain, so for example, we often design to Euro codes. So there's certain codes that you design to make sure that it will work. But I think the other side of it, which sometimes makes it more challenging, is that either you're working with a really complex detail that doesn't quite fit into all the standard data tables or anything like that. So yes, there's obviously standards that you can follow and keep to, but when you get complex challenges, that's when it become a little bit more difficult.
Is it quite a collaborative role? Do you find that certainly younger engineers feel comfortable asking for help and advice, or is it quite sort of independent work where people don't necessarily want to let it be known they don't know the answer to something?
A bit of both, I would say, probably. I think there's obviously different personality types, but probably a bit of both in terms of what they go. And I think, one thing that's quite common is to do product manufacturers will do CPDs to try and educate on products and when that can be used. But yeah, a mixture.
Can you just explore that a little bit more for those that don't know CPD?
Yeah, it's a continual professional development. So product manufacturers will come in and deliver a presentation on a particular area. So for example, we have one on designing with a congested cavity, and so that goes into topics around how to design masonry support with cavity trays, with fire barriers, with wall ties to create a buildable solution. And I think when an engineer comes in, graduates from university, there's obviously base fundamentals there, but there's probably sometimes a lack of experience within real systems, and I think sometimes that helps bridge the gap with those types of presentations.
And so they earn a certain number of points or something for doing a CPD and have to keep a certain number per year?
Yeah, they do, I think, to keep their accreditation going each year. Yeah.
Like a pilot having to do a certain number of flight hours.
Training, yeah. I know which one I'd prefer to do, yeah.
And how do they typically choose or find which CPDs that they're going to engage in?
Yeah, probably a bit of, I would say, project specific. Obviously, if they've got a challenge that they've not dealt with before, I think that might be a good trigger to go and find someone who might be able to help with that. But then they'll typically have a kind of at least a monthly basis where they've got people coming in to deliver those.
So CPD obviously helps them with their professional development. Are there other ways that you see engineers developing themselves professionally, upgrading their skills?
Yeah, I would say the biggest one is actually getting on site and seeing the real challenges that happens. It's certainly for me personally as well, is that it's all good looking at drawings and trying to design to a particular section, but actually when you get on site and you see the physical problems, whether it made from an installation perspective is one of the biggest ones, is okay, you've got this bracket and it's fixing here, but like what happens on site when you've potentially got this in the way or this in the way, and there's an order of building things, it suddenly becomes a lot more challenging. And I think, that's the biggest thing.
Totally. Like they say, you can't learn to ride a bike by reading a book. You've actually got to get on the bike and then figure it out. And I can imagine with certainly the way that building design and technology is moving forwards, that you've actually got to see these things in situ to really understand the decisions. Yeah,
and get down to a product manufacturer as well. That's the other side. One is the terms of on-site, but can this thing be made? Understanding manufacturing processes and what needs to go into the consideration when designing certain products, etc. If you get down to a manufacturer, they could probably give you a tour of their facilities, and you can start to open your eyes about considerations other than just, does this work or not?
With that in mind, how important are actual personal relationships between an engineer and the various manufacturers and the engineers at those manufacturers that they're working with?
Yeah, really important. I think they can almost be a partner, and certainly enables them to create buildable solutions, just pulling on a manufacturer's experience.
So, an engineer is working with a manufacturer, they've specified specific products. What they're really aiming for, from what you're saying, is sort of peace of mind that what I've designed is going to build and it's going to stay up. When you're speaking with engineers, what does peace of mind mean to them? How does that really get manifested?
I think it's about managing their workload so that they know that they're completing their deliverables on time, but also making sure that the stuff they're completing is correct. I think that's probably the biggest thing. So yeah, time management and comfort that the designs they've produced are correct.
And so thinking through the kind of support they'd get, this personal relationship with a manufacturer, what does that relationship typically look like? What types of calls or conversations are happening? And is that just a sort of one-off, what product should I choose? Or does that carry on throughout the build phase of the project?
Yeah, usually it carries on. Initially, when there's some conceptual designs being produced, then there's some early conversations. But as things get progressed, there's, potentially any tolerance things, or if something isn't quite where it was supposed to be, what advice on what can be done. So really, it does carry on throughout the whole process.
And is a lot of what they're designing bespoke, or is there quite a bit of standard work as well, and it's just about choosing the right product?
I think there's way too much bespoke. That's probably one of the problems, actually, is that the wheel is reinvented all the time. And I think us as manufacturers are obviously trying to create some standard solutions to that. And so we need to obviously engage with engineers and create those standard products that fit for purpose. And then we don't have to design, a custom bracket each time. Mm.
Yeah. Is the customer always right, or do you push back?
A mixture, I would say. I think they obviously encompass their remit is usually a bit wider in terms of all other things that need to be considered. But we're obviously kind of specialists in a particular area, and I think that's where you kind of need to balance the two.
I mean, what would be some scenarios where you would advise or support something bespoke versus a standard product?
I think we've got certain ranges that fit. So, for example, if it's a certain cavity, if it's a certain weight, then we would have a standard solution for that. But obviously, if it falls outside of that, then we don't have anything. Then 100% design a custom solution for that. But I think you just want to make sure that you're looking for those standard solutions first before, designing something custom each time. And the reason for that, just so to say, is that often we spend a lot of time, R&D in making like efficient solutions for that. So we can make a product more effective, both from a like install and a cost perspective, because we spent some time researching and developing that, than having something which is a bit, more clunky. You wouldn't go and aim to try and build a better Ferrari or road car than you can. It's just reality is that they spent a long time developing that. But if you need something super custom, then again you might go to someone else.
We touched earlier on building regulations and how they change, and the challenge for engineers to keep on top of things. When you think about CFS and maybe some of your standard products, how are you helping engineers to keep on top of building regs and being able to specify the right products?
So through our Insight articles, we're trying to push some content out on that, deliver the CPDs to make sure if anything's changed. The software that we're developing now is web-based, and so that's kind of automatically up to date. But generally, just is staying in touch and with kind of all of the resources that we're producing.
So the engineer has specified their products. They've got their design sort of locked down. A key part of their role is then to go and to pitch that to the quantity surveyor or the buyer, whoever's going to be agreeing the contract. How can CFS help that engineer to be able to prove their design and to validate that's the right product to be using?
I think a couple of ways. One being that it's proven that this is an efficient solution for the job. Making sure that they understand the kind of the cost and the budget for these things, so that they can actually prove that, but also understanding like lead times, etc. So making sure that when this job does come into build phase, that you can source the products efficiently and keep the program on schedule.
Brilliant. Coming to the end of our conversation, obviously we've talked about, as an engineer, so it's a high risk role. You've got a lot of responsibility on your head, and you're juggling these multiple projects. When you're speaking with engineers in the community that have worked with CFS, what are you hearing about how them working with CFS has helped them to do their work?
I think it's just being experts in what we do. And so, often they've got, as I mentioned before, they've got quite a wide remit sometimes. So it's nice to be able to partner with someone who can provide some really good technical advice on some of the problems they've got, but also not just restricting it to, a standard set of data pages or etc., but like going beyond that. We've done extra testing on our products, and so we're able to be that kind of value add insight into basically solving problems for them.
And if I was a new engineer, I've just come out of education, got my accreditations, and I'd never heard of CFS. What would be a great way for me to get up to speed on how CFS works and why I should be considering specifying some of your products?
Listen to us on YouTube, follow the socials, request for a CPD. We come and do a presentation on our products, but obviously we are trying to create new content, and or just pick up the phone. We can speak to you and have a good conversation and run through things.
Fantastic. Well, thanks for joining, Henry. Look forward to seeing you on a future episode.
Thanks.